Hey everybody, today we are going to derive the formula for the surface area of the sphere. So, we're going to find the surface area of the sphere by creating something called a nearly pyramid. So, here I have a sphere with almost a pyramid that comes out from the center to three different points on the surface of the sphere. Okay. So how are we going to do this? Well, let's see. Okay, so here's what we're going to do. The volume of the sphere is going to equal 1/3 the area of the base times the height. So we're going to treat this thing here like it's a cone, okay, or a pyramid. We're going to take 1/3 the area of the base times the height. Now the height is going to be the radius. It's going to go from the center to the center of this. But keep in mind, these are all radii right here because they all touch the surface of the sphere all the way around. So we're going to take this one. We're going to call this 1/3 the area of base 1 times the radius. And then what we're going to do is take another pyramid right next to this. And we're going to take 1/3 the area of the base of that one. Notice this one's base 2 times the height is going to be the radius plus 1/3 the area of base 3 times the radius. What we're going to do, and notice we've got plus ... plus 1/3 base n times the radius. So what we're doing is taking an infinite number of volumes of these type of shapes until we fill up this entire sphere with those shapes. That's going to be the volume of the sphere. Okay. Now, we already know that the volume of a sphere is 4/3 pi r cubed. So what we can do, somewhere I've got it here. Here we go. We can substitute 4/3 pi r cubed for the volume. We can just put it in right here. Okay. So we're going to take this, we're going to substitute it in here, and we get this formula right here. So the volume is all of this. Okay. Now, we're going to take all of that. We're going to factor the 1/3 out of all of these. We're going to move it out to the front. And we're also going to factor out the r. So we've got 1/3 r times base 1 plus base 2 plus base 3 plus ... plus base n. Okay. Now, if you think about it, if I add up, let's say this is base 1 right here. Okay. If I add up all those bases all the way to the nth one, this right here is going to be the surface area. Okay. So now we're going to multiply both sides of this equation by 3. That's going to cancel out the thirds here. Okay. And we're going to get this. 4 pi r cubed is going to be left over here. And the 3 is going to cancel the 1/3, and I get r times all this. Okay. Now, I can divide both sides by r. So I'll just do that. Divide this whole thing by r. Let's move this down a little bit so you can see that. Okay. So this r is going to cancel out that one, and I get this right here. And this r is going to cancel one of those, and so I'm going to get r squared. Okay. And then I'm just going to take this. This is just the surface area. And there is my formula right there. Surface area is 4 pi r squared. Okay. So we're going to go ahead and use that to find either the volume. We did the volume last time. We're going to find either the volume and the surface area of each one of the solids in these figures right here. And these little story problems that we've got right here. Just a quick little lesson on how to derive the surface area formula. Have fun with that. I'll see you guys later.